Okay, Financial Math Grade 12 Exam Questions May-June 2023 Paper 1. This is question 6 from DBE. Okay, this is the question 6 from May-June 2023 from DBE. Okay, so the total is 13 marks. Okay, let me get the question again. Question 6 from May-June 2023. Okay, this is the question 6 from May-June 2023. Okay, 6.1. A company bought a photocopier for 150,000 rand on 1st July 2022. They will use the old photocopier as a trade-in when they replace it with a similar new photocopier in 5 years' time on 30th June 2027. 6.1.1. The average rate of inflation over the next 5 years will be 6.5% per annum. Determine the price of a similar new photocopier in 5 years' time. 2 marks. Okay, when the photocopier is bought, it's new. After some times, it's going to be old, and they are going to trade it for a new one, a similar one. Okay, now the question is, determine the price of a similar new photocopier in 5 years' time. Whenever they are talking about rate of inflation, you know that there is an increase in prices, okay? Whenever they are talking about inflation, they are talking about an increase in prices, okay? Now, you don't have a situation where a regular payment of money is paid over a period of time. You don't have that situation. If you have that situation, you are going to use the future value formula, okay? You have a photocopier which is bought for 150,000 rand, and then after that the price is going to increase, okay? Inflation, the price is going to increase after 5 years, okay? So with this in mind, you are going to use the compound interest formula, this one, okay? This is the compound interest formula with a positive, okay, not negative, with a positive because there is an increase in price, okay? Rate of inflation, increase in price. So your initial is P. P is equal to 150,000 rand, okay? This is your initial. And you have I, the interest rate, is equal to 6.5% per annum. You are going to divide by 100. This is 0.065. And N, this is equal to 5 years. Okay? So the question is to determine the price of a similar new photocopier in 5 years' time. Okay? This is why we have N is equal to 5. Okay? You have to determine A. So A is equal to, you are going to plug everything that you have into the formula. This is what you have. So A is equal to, use your calculator. I'm going to use my emulator. Okay? You can use your calculator to check with me the answer. So this is what I have. Okay, this is equal to this. So you have 205,513. Okay, when you round off to 2 decimal places, you are going to have 100 cents. Okay, 100 cents. This is 1 rand. So you add it to this. Now you have 513. So this is the final answer to question 6.1.1. Okay. Let's move on. Now 6.1.2. Okay. 6.1.2. Calculate the trade-in value of the old photocopier after 5 years if it depreciates at a rate of 9% per annum on a straight line method. Okay, 2 marks. So you must be familiar with these words. Okay, let me show you. when they talk about reducing balance method, okay, when they talk about reducing balance method, you are going to use this formula. This is the same as this, but you have minus there because they are talking about reducing, okay? So this formula is known as the compound decay formula. This is the compound interest formula. This is the compound decay formula. And whenever they are talking about straight line method, as in this case, straight line method, okay, you are going to use this. You can see you have n multiplied by I. N is not an exponent, as in this case, n is multiplied by I. Okay, so you are going to have plus, but you have to pay attention to what you are told. You are told that calculate the trade-in value of the old photocopier after 5 years if it depreciates. Okay, if it depreciates. On a straight line method, you are going to have minus. Okay, so when they say straight line method, you have this formula. This formula is known as simple interest formula. Okay, simple interest formula. They can also say straight line basis. Okay, straight line basis. You are going to have the same formula. And again, this is called simple interest formula. Or they can say straight line depreciation. You can see you have the word depreciation. When they say straight line depreciation, you understand you are going to have minus. Okay, minus because of depreciation. So you are going to have this with minus. Okay, so this is known as simple decay formula. Okay, simple decay formula. So whenever you have a minus, you are going to have the word decay, which means decrease. Okay, whenever you have a minus, you are going to have the word decay, which means decrease. Okay, so in this case, you are told calculate the trade-in value of the old photocopier after 5 years if it depreciates. If it depreciates, okay, you know that you are going to have minus. You also have another piece of information. On a straight line method, okay, you are going to have n multiplied by I, not n as an exponent. Okay, whenever you have the word straight, the keyword is straight. Okay, you can see straight, straight, straight. You are going to have n multiplied by I, not an exponent. Whenever you have straight, 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 you have n multiplied by I. Okay, you can see that. And you have depreciate, you are going to have minus in the formula. Okay, depreciate means decreasing. You are going to have a minus. You are going to use this formula. Okay, so the initial price P, the interest is 9% per annum. Okay, so I is equal to, you divide 9 by 100, you are going to have 0.09. Okay, divide by 100, and n is equal to 5 years. Okay, n is equal to 5. So A, the final price, is equal to, plug everything that you have into the formula. You have this. Okay, times n is 5. Okay, times n. So A is equal to, you can use your calculator to check with me the answer. Okay. This is what you have. 82,500 rand. Okay, you can see the price went down. Okay, so let's move on. This is the final answer to question 6.1.2. Now question 6.1.3. Okay, 6.1.3. So let me do this. The company set up a sinking fund to cover the replacement cost of the new photocopier. the fund earns interest at the rate of 7.85% per annum compounded monthly. The company made its first monthly deposit on 31st July 2022 and will continue to do so until 31st May 2027, 1 month prior to the new photocopier being bought. How much should be deposited at the end of each month so that the company will be able to buy the new photocopier? Okay, 4 marks. So the company set up a sinking fund, meaning the company started saving. They started saving so that they can have enough money in future to buy the new photocopier. Okay, so the sinking fund is going to be the amount they need on top of what they are going to get from the old photocopier. Okay, because they are going to trade it and get some money. What they are going to need on top of that, that will be the sinking fund. So when you check from the previous question, this is the value. So the sinking fund will be the amount that they need on top of this so that they can afford the new photocopier. The price of the new photocopier is this one because the price went up. You need to find how much you need on top of this so that you can afford this. Okay, that will be the sinking fund. So the sinking fund will be, you have this minus this, okay, minus this, which is equal to, when you plug in your calculator, you are going to get this. So this is what they need on top of this. So this is the sinking fund. This is what they want to achieve in future. So this is the reason for setting up a sinking fund. Okay, they want to achieve this amount in future, plus this, they are going to afford to buy this. Okay, now the question is to find how much should be deposited at the end of every month so that they can have this in the future. You understand? You are going to use the future value formula. Okay, another piece of information is the interest. The interest is equal to 7.85 divided by 100. You are going to get 0.0785 divided by 12 because this is compounded monthly. Okay, now let's draw a timeline so that you understand what you are requested. Okay, we are going to draw a timeline. Now the timeline will be over a period of 5 years. Okay, 5 years. You can see 2022, 2027, 5 years. So let's do this. So you have from the start, the old photocopier is bought, okay, from the start. So 5 years there, they are going to trade it, okay, trading of old photocopier on 30th June 2027, okay, you are given that, okay, they are going to replace it in 5 years time on 30th June 2027, okay, this is what you have. And in 5 years, they are going to buy a new photocopier. So from that moment, they started saving. They set up a sinking fund. Okay, this is what you are told. They set up a sinking fund. The company made its first monthly deposit on 31st July 2022. Where is this? You can see the old one was bought on 1st July 2022. So this is 1st July 2022. And the first deposit was done 1 month after that. Okay, so after 1 month, they, okay, first deposit. Okay, I hope you can see that. Okay, so let's carry on. And you are told, you can see the last will continue to do so until 31st May 2027, 1 month prior. Okay, meaning before, 1 month prior to the new photocopier being bought. Okay, the new photocopier is bought there. 1 month, the last deposit is done. Okay, last deposit. This is what you are told. Okay, they will continue to do so until 31st May 2027, 1 month prior to the new photocopier being bought. Okay, 1 month. This is 1 month. Okay, so this is what you have. Let me close this for now. I want to show you how you can count the number of payments or the number of deposit. Okay, you have your first deposit day and your last deposit day. Okay, let me show you this counting number of payments or deposit. If you have end of same month to end of same month, okay, multiply number of years by 12 because you have compounded monthly. You are going to multiply number of years by 12 and then add 1. Okay, let's see an example. Example, if you have 31st July 2022 to 31st July 2027. Okay, first deposit is done here and then last deposit is done here. So this is what we mean, same month. Okay, July. You are going to take the number of years, you multiply by 12 and then you add 1. So the number of years, you can see you have 5 years. Okay, 2022 to 2027. This is 5 years. So you are going to have n is equal to 5 multiply by 12 because this is compounded monthly and then add 1. Okay, plus 1. So this is 60 plus 1. This is 61. Okay, 61 payment or 61 deposit. Okay, it can be end of January to end of January or end of February to end of February or end of December to end of December. Okay, whenever it is the same month, you are going to use this method. So we are going to use what you have just learned and apply it here. You have end of May 2027. Okay, 2 months. 2 months back. Okay, you are going to have 59. Okay, so you have 59 payment. Okay, or 59 deposit. If you don't have the same month to same month, you are going to know if you have to go backward or forward. In this case, we went backward by 2 because we have end of May, not end of July, but we have end of May. We went backward by 2 months. Okay, the new photocopier is bought there. The last deposit is done here. So the money is left for 1 month growing. Okay, 1 month. We need to find X. So we are going to use the future value formula. Remember, you are going to use the future value formula for this part. And you have the money growing for 1 month. So you are going to multiply by this. This is from the compound interest formula. Okay, from this formula, you can see this part. This part, okay. N is equal to 1. Okay, 1 month. So N is equal to 1 month. Okay, N is equal to 1 month. So X is equal to, we are going to take this to the top. Now you have F times this. Okay. When you take this to the top, and you are going to take this to the bottom. So over this, okay, this times this. So this is how you can solve for X. Now X is equal to, plug everything that you have into the formula. You know F is equal to this. This is F, the future value. I is equal to this. N is equal to 59. This N is equal to 1. So you have this. Okay. There is an invisible 1 there. N is equal to 1. There is an invisible exponent of 1. So X is equal to, when you plug this in your calculator, you are going to get this. Okay. You can check with your calculator. So this is the final answer to question 6.1.3. Okay. Okay, 6.2. Let me get the question again. Okay, question 6 from May-June 2023. Okay, now we are going to solve question 6.2. Okay, today Andrew borrowed 200,000 rand from a bank. The bank charges interest at 5.25% per annum compounded quarterly. Andrew will make repayment of 6,000 at the end of every 3 months. His first repayment will be made in 3 months from now. Okay. How long in years will it take Andrew to settle the loan? Okay. 5 marks. So we are talking about a loan. Okay. We are talking about a loan. You understand? You are going to use the present value formula. Okay. Whenever we are talking about a loan, you are going to use the present value formula. Okay. You can also use the present value formula whenever you have the money right now, like right now, not investing or saving to have the money in the future, but you have the money right now. So whenever they are talking about a loan or you have the money right now, you are going to use the present value formula. Okay. You are given the value of the loan. Okay. You are given the value of the loan. You have 200,000 rent. Okay. This is P. And you are told the repayment is 6,000. Okay. This is X. 6,000. Okay. And you are told the bank charges interest at 5.25% per annum compounded quarterly. So I is equal to, you divide by 100, you are going to have 0.0525 and then divide by 4 because this is compounded quarterly. Okay. Now, when you continue with the question, you are going to see that Andrew will make repayment of 6,000 at the end of every 3 months. Okay. His first repayment will be made in 3 months from now. Whenever we talk about compounded quarterly, this is what you have to understand from the timeline. Okay. This is compounded quarterly. You have every 3 months. Okay. After 3 months, you have a payment. And then after another 3 months, you have another payment. After another 3 months, you have another payment. After another 3 months, you have another payment. This is 1 year. Okay. This is 1 year. You can see you have 4 quarters. Okay. 1, 2, 3, 4. 4 quarters in 1 year. This is what compounded quarterly is. Okay. Every 3 months. You can see 3, 6, 9, 12. Okay. Every 3 months. This is what compounded quarterly is. So this is compounded quarterly. Now, there is nothing that you are going to manipulate. Okay. Because Andrew is doing it the right way. Okay. Andrew is making repayment every 3 months. You can see that every 3 months. Even his first repayment will be made in 3 months from now. Okay. So Andrew is doing it the right way. There is nothing that you are going to manipulate in this formula. Okay. You have to make sure your interest is divided by 4 and n is multiplied by 4. You have to make sure you do that. Besides that, you are going to manipulate nothing. So let's carry on. The question is to find how long in years will it take Andrew to settle the loan. Okay. You have to calculate n. Okay. Now you are going to plug everything that you have into the formula and then try to find n. Okay. So P is equal to this. Okay. This is equal to X is equal to this. You have your square bracket 1 minus and then your round bracket 1 plus I. This is I. You close your bracket minus n. Make sure you multiply n by 4. Okay. Because this is compounded quarterly. Okay. Close your square bracket over I. This is I. Okay. Now I'm going to manipulate this so that I can solve for n. Okay. So I'm going to keep this, what I have in square bracket alone, so that I can solve for n. Okay. So I have 200,000. I'm going to multiply by this. You are going to take this to the top. Okay. You take it to the top. Now you have this. And then you are going to take this to the bottom. Okay. You take this to the bottom. 6,000 to the bottom. This is equal to, now you have this alone, okay? So you have 1 minus, you have this, you have 1 plus this, okay? Close your round bracket. Now you have negative 4n, okay? Negative 4n. So from here, what I can do is to take this part to the left, okay? Minus, it's minus there. When you take it to the left, you're going to have plus, okay? This is equal to, you still have 1, okay? You still have 1. You can take this to the right, you're going to have minus, okay? You have plus there. When you take it to the right, you're going to have minus, okay? Minus, like this, okay? You can see. To the right, now you have minus, okay? So, we have this. Let's see what we have in a round bracket. Let's see what we can have. So, in the round bracket, we have 1 plus this. Okay, this is what I have. This is equal to this. Okay, this is not rounded off. Okay, we can use this number or you can use the fraction. Okay, so let's do this. I have this, okay, in brackets. So remember, to the power of negative 4n. This is equal to, let's see what we can get from here. Okay. Okay, I hope you can see that. Okay, I have 9 over 16. I can write it as a fraction or as a decimal. Okay, you have 0.5625. Okay, 0.5625. Okay, this is what you get from this. Okay, from this, you have this. Now, let's close this and let's close this. Okay, now the question is to find n. Okay, you have to find n. So you have negative 4n. This is an exponent. Since you have it as an exponent, you can introduce log on both sides of the equal sign. Okay, you can introduce log there and log there. Or you have negative 4n, this is your exponent. The exponent negative 4n is equal to log what was written as a base, write it as a base. So you have this. You have it written as a base, log of this, okay? So log of this to base this. Now you are going to solve for n, okay? You are going to divide by negative 4 on both sides so that you can solve for n. When you divide by negative 4, you have n is equal to, you're also going to divide this by negative 4, okay? So let's use our calculator. You can use your calculator to check with me. So I have this. I'm going to use this log, okay? This is your base, 1.013125, okay? This is what I have. And then log of this, 0.5625, okay? Divide by negative 4 because you are trying to solve for n, okay? Divide by negative 4. Now you have this, okay? So you have 11.03 years, okay? So when you divide by negative 4, now you have your final answer in years, okay? 11.03 years, okay? So we will be posting more videos, so make sure to stay tuned and consider subscribing for more learning. Until next time, I will talk to you soon.